All right, in this video, we're going to learn about Module 7, Lesson 5, simplifying radicals and multiplying and dividing with radicals. All right, you should have 3 pages of notes. We're going to start by learning how to simplify them, and then we're going to start multiplying and dividing with them. All right, so your warm-up for this module is taking what we learned previously in 7.4, which is rational exponents and exponent properties, and applying it together. So we have 16 to the 1/4 power multiplied by 16 to the 1/4 power. So according to my product property rules, if I have the same base, I can add the exponents. So 1/4 plus 1/4 simplifies to be 1/2. So 16 to the power of 1/2 is the same thing as having the square root of 16, which hopefully you know and remember that the square root of 16 is equal to 4. So that's just one example of using rational exponents that we learned in our previous lesson. All right, so simplifying radicals. So a radical is just said to be the simplest form when the number underneath the root has no square factors or cube factors for a cube root. So in order to do this, we first must remember what our perfect squares are. So 1 squared, well, is just 1 times 1, which is equal to 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Please note, if you are not understanding this pattern, that I am just squaring a number, please go back and look at what it means to be a perfect square, or come and ask me in class, because I still see students doing 4 to this 2 power is 8 because they're multiplying the base times the exponent, and that is not correct. We are actually squaring the base, so multiplying it times itself. 5 squared is 25. 6 squared is 36. And so I'm going to go ahead and finish filling out this table. And the reason why I am filling out this table, you'll see in just a moment, because there's 2 different methods we can use to simplify radicals. We can either use method 1, which is prime factorization, which means that we are going to take that number 72 underneath that radical and break it down to its prime numbers. And if you don't remember what your prime numbers are, here is a chart of your prime numbers. And so 72, if I asked you for 2 numbers that multiply together to give you 72, I believe most of you are going to tell me 8 and 9. So if I give you 8 and 9, or if you gave me 8 and 9, I now need to break 9 down into its factors. Well, 2 numbers that multiply to give me 9 are 3 and 3. Those are prime numbers, so I can stop there on that side of my factor tree. And now I need to factor number 8. So 8 breaks down into 4 and 2. 2 is a prime number, so I can stop there. 4 can be factored into 2 and 2. So 72 becomes 2 times 2 times 2, because I have 3 2's in my factor tree, times 3 times 3. All right. So in order to simplify a radical, I am looking for pairs of numbers here. And the reason why I'm looking for pairs is because the index here is 2. Remember, if the index is not written, it is an implied 2. So because I have a pair of 2's, I can take those pair of 2's out of the house and it becomes 1, 2. I have a pair of 3's. I can take that out of the radical and it becomes 1, 3. So now I just have to simplify. 2 times 3 is 6. And I am left with 1, 2 underneath the radical. So I have 6 square roots of 2. Now, there is also another method, which some people prefer to use, which is the largest perfect square. So if I have 72 and I am looking for the largest perfect square that divides into 72, that would be 2 and 36. And the reason why I'm leaving it underneath the radical sign is because then you should be able to identify 36 as a perfect square, and the square root of 36 is equal to 6. So since the square root of 36 is equal to 6, and I still have the square root of 2, I'm just going to have 6 square roots of 2. 2 different methods to simplify radicals. Obviously, this looks like the easier one. However, students have to recognize and remember, basically memorize what their perfect squares are in order to use this method. All right, so using either method to simplify the radicals below, I have the square root of 24. Well, 24 can be broken down into the factors 12 and 2. 12 can be broken down into 4 and 3. And 4 can be broken down into 2 and 2. So now you'll notice underneath the radical, I rewrote that in expanded form as 2 times 2 times 2 times 3. Because my implied index here is 2, I'm looking for two numbers underneath the radical. So I can take them out and it becomes 1. I have 1, 2 left and 1, 3 left. There is nothing I can do with a single number underneath the radical. So I'm just going to multiply those back together and I get 6. So I have 2 square roots of 6. Now in this next example, I'm looking for the third root of 81. Well, 81 can be factored into 9 and 9. 9 can be factored into 3 and 3. And so the cube root of 81 could be rewritten as the cube root of 3 times 3 times 3 times 3. Now, because my index here is 3, I have to have 3 numbers underneath the radical in order to take one out. So I have 3 numbers, 3 threes. I'm going to take it out of the radical, and I have 1 3. And then I am left with the cube root of 3. So that simplifies to be 3 cube roots of 3. All right. It's really not bad. It's kind of fun once you get the hang of it. So just bear with me and keep practicing. So here we are going to simplify the radicals below. You may use either method, either use the factor tree, so break down 192 and 40 into all of its factors, or you can use your perfect squares, or if you know your perfect cubes. All right, so the answer, the square root of 192, simplifies to 8 square roots of 3, and the cube root of 40 simplifies to be 2 cube roots of 5, and that's because 40 can be written as 8 and 5, and the cube root of 8 is equal to 2. All right, so how does this all relate to multiplying and dividing with radicals? Well, radical expressions can only be multiplied or divided if they have the same index or root. So if I have square root and square root, I can multiply them together. But if I had a square root, like 2 to the square root times the square root of 8, and the third root of 12, there would be nothing I could do with that. I cannot multiply them unless they have the same root or index. So when multiplying or dividing radicals, we need to multiply or divide the coefficients. So the outside times the outside. And then we do the radicand. So the numbers underneath the radical, which is the inside of the radical, times or divided by the inside. Okay, so let's take a look at our first example here when we are multiplying. We have 2 times the square root of 8 multiplied by 3 times the square root of 4. Well, I'm going to do 2 times 3. And then I'm going to do the square root of 8 times 4. So that becomes 6 square roots of 32. But I'm not done because now I must simplify that radical of 32. Well, the square root of 32 can also be written as the square root of 16 times the square root of 2. And the square root of 16 is equal to 4. So because 32 simplifies into 4 square roots of 2, I now have to multiply 6 times the 4. So I'm going to get 24 square roots of 2. Here I have the cube root of 12 multiplied by the cube root of 6. I do not have any coefficient, so I'm just going to multiply 12 times 6, which is 72. The cube root of 72 can be written as the cube root of 8 and 9. If I finish factoring this completely, you'll see that I have the cube root of 2 times 2 times 2 times 3 times 3. I have 3 2's underneath the radical. I can take it out. It becomes 1 2. And then underneath the radical, I'm left with 3 times 3. So I'm going to end up with 2 cube roots of 9. Okay. you'll find that this is the rare time that you will actually prefer to divide, because when we are dividing radicals, we often no longer have to simplify because they're already in simplest form. So we're going to follow the same method that we did before. Outside divided by the outside, inside divided by the inside. So 18 divided by 3 is equal to 6. The square root of 10 divided by 2 is the square root of 5. So my answer is just 6 square roots of 5. No simplifying needed. Here I have 24 cube root of 36 divided by 4 cube root of 12. So I'm going to do 24 divided by 4, which is equal to 6. 36 divided by 12, which is the cube root of 3. So I have 6 cube roots of 3. For once in your life, you're going to prefer to divide over multiply. All right, here are your checks. Go ahead and try these on your own. Pause the video, then come back to see if you have them correct. All right, hopefully you did well. Your first answer is going to be 60 square roots of 3 once you simplify it. 3 square roots of 5. 3 cube roots of 6. And the cube root of 3 divided by 3. The reason why I ended up with a radical up top is because I had a larger number, 81, divided by 27. So I no longer have a radical in my denominator. So I would write it as cube root of 3 divided by 3 because my larger coefficient was in the bottom. So be careful and make sure you're following the rules and not getting rid of the fraction just because you don't like fractions. All right, here's your practice. You can work with others, or you can ask for help in class, and I will help guide you.